Welcome to the Unit 3, Section 6 video on linear inequalities. A linear inequality is similar to a linear equation, but the equal sign is replaced with an inequality symbol. A solution of a linear inequality is any ordered pair that makes the inequality true. So we're going to tell whether the ordered pair is a solution of the inequality. So here we have y is less than x minus 1. A possible solution is the 0.73. So to see whether or not this is a solution, you simply take your inequality, plug in 3 for y and 7 for x, and see if what we have is true or false. And in this case, we have a true statement. 3 is less than 6. So the 0.73 is a solution. In this example, y is greater than 3x plus 2, and our possible solution is the 0.45. Again, we're going to take our inequality, plug in our 5 for y, and our 4 for x. 3 times 4 is 12, and 12 plus 2 gives us 14. 5 is not greater than 14, so therefore the 0.45 is not a solution to this inequality. A linear inequality describes a region of a coordinate plane called a half-plane. All points in the region are solutions of the linear inequality. The boundary line of the region is the graph of the related equation. So this is what a linear inequality looks like graphed. In fact, on this graph, we have two linear inequalities that are graphed, one on the upper left and one on the lower right. So let's talk about what all these things mean. When the inequality is written as y is less than or equal to, or y is greater than or equal to, the points on the boundary line are solutions of the inequality, and the line is solid. When the inequality is written with less than or greater than, the points on the boundary line are not solutions of the inequality, and the line is dashed. So the takeaway here is a solid line you use for greater than or equal to or less than or equal to, including those solutions. For greater than or less than, you use a dashed line to indicate that you are not including those solutions. Now for the shading, when the inequality is written as greater than or equal to, the points above the boundary line are solutions. When the inequality is written as less than or equal to, the points below the boundary line are solutions. Now keep in mind here, when we're talking about shading above and shading below, the y must be on the left-hand side for these rules. So when graphing linear inequalities, solve the inequality for y, graph the boundary line, use a solid line for greater than or equal to or less than or equal to, use a dashed line for greater than and less than, shade the half plane above the line for y is greater than or equal to, shade the half plane below the line for y is less than or equal to, and then check your answer. Note, when checking your answer, the 0.00 is a good test point to use if it does not lie on the boundary. It's a good test point because it is easy to work with, 0 and 0. So we're going to graph the solutions of each linear inequality. So starting with this one, y is less than 3x plus 4. We graph it by finding our slope, which is 3. So we have our y-intercept of 4. So you plot your y-intercept at 4, y equals 4. And then you're going to do your slope of 3 by either going up 3 and to the right one or down 3 and to the left one. Okay? And then you're going to shade your graph. Because we have less than, we have a dashed line, and because it is less than, we shade below the line. So all your y values below 4 are going to be shaded, and you'll be shading on that side of the graph. So let's do a check. Let's take the 0.00, which should be part of the solution set, and see if we get a true statement. We plug in 0 for x and y, and we get 0 is less than 4, which is true, and we have correctly graphed it. For b, we have 3x plus 2y is greater than or equal to 6. Well, we need to rearrange this into slope-intercept form so we can get the slope and the y-intercept to graph. So 2y is greater than or equal to negative 3x plus 6. We subtract 3x from each side, and then we divide each side by 2. So our slope is negative 3/2, and our y-intercept is 3. So start with plotting your y-intercept at 3, then use your slope to finish plotting your line, and it is got an equals to component, so it will be a solid line. And then you're going to shade above because we have a greater than. Now that we have the graph, now let's take a look and see if 0, 0 is not a solution because it lies outside the solution set. Let's see if we get a false statement. So plug in 0, and we get 0 is greater than or equal to 6, which is false. So therefore, we are good to go. A similar process can be used to write a linear inequality when given a graph. You're going to identify the slope and substitute that in for m. You're going to identify the y-intercept and substitute that in for b. You'll determine the inequality sign that is being used. If it's shaded above the y-intercept, use greater than or equal to. If it's shaded below the y-intercept, use less than or equal to. If the boundary is solid, use greater than or equal to or less than or equal to. If the boundary is dashed, use greater than or less than. So we're going to write an inequality to represent each graph. Starting with the first one, we're going to identify what our slope is and our y-intercept. Our y-intercept is 2. Our slope is down 1 and to the right 3, so negative 1/3. We have a dashed line, so it's going to be either greater than or less than, and because it is below the line, or our boundary, we're going to use less than. So y is less than negative 1/3 x plus 2. For b, we have a y-intercept of negative 2. We have a slope of up 3, or I should say up 5, and to the right 1. So our slope is 5. And we have a solid line, so we'll have an equals to component, and because we are shaded above the boundary, it is going to be greater than or equals to. So our inequality is y is greater than or equal to 5x minus 2. Now for this one, we know that this is not a linear function because it's not a function at all. It is a vertical line, but still, how are we going to handle this? Well, remember, when we have a straight line up and down, we use our x value. And because our y-intercept is not there and our slope is undefined, we're going to go to our x value of negative 2, and it's all the values that are shaded to the right of negative 2. So you can think of this as like a number line. All the values greater than negative 2 are shaded, so we are going to have x is greater than or equal to negative 2. Thanks for checking out my video in the Algebra 1 Honor Series. You can subscribe to my channel. I've got the next video queued up for you, and if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.